Hi folks, I'm Joe Binder, Principal Program Manager on the Azure Developer Experience team. And today, I'm going to walk you through the process of deploying a Spring Boot app to Azure. We'll focus on deploying to Azure Web Apps and to Kubernetes on Azure Container Services, two of our most popular offerings for Java apps today. If it's been a while since you've looked at Azure, or you're new to the platform, I think you'll find the next few minutes a useful way to get your existing Java apps up and running on Azure quickly. For this demo, our app will be running in a Docker container. The sample I'm using is incredibly basic, but the steps we'll use to deploy it will be the same for virtually any containerized Java app you're working on. I'm going to show you the steps entirely in the command line, so you can just follow along, pause the video, and refer back to the commands if you get stuck along the way. We also have a comprehensive set of documentation for the steps I'll demonstrate on docs.microsoft.com, and there'll be links to those articles at the end of the video. Before we get started, there are just a few tools you'll need on your machine: a Git client, Maven, Java, and the Azure Command Line Interface 2.0. All stuff you probably already have. Let's get started by cloning the sample repo. This is a really simple Spring Boot sample, but feel free to use any app you'd like, as we won't be changing any of the code in this demo. I've cloned the repo, and I'm just going to move into the completed sample, because we're not really concerned with what the app actually does in this case. Now I'm going to log in with the Azure CLI using the AZ login command. If you haven't logged in for a while, you're going to have to follow the URL here to get all set up. But the credentials are valid for 90 days, and I'm already logged in, so I'm going to skip that step. Next, we're going to create a resource group. We're going to put all of the resources for this demo in the same resource group. So you can just delete the resource group when you're done, and all the infrastructure we create will be disposed. You won't have to pay for it later. All of the AZ CLI commands expect a resource group too. So let's just go ahead and set the group we just created as the default. I'm going to go ahead and set the default location to West US as well, just so I don't have to specify it later. All right. Our app runs in a Docker container, so we'll need a container registry to store and manage the container images. You can use any registry you'd like, but today I'll show you how to create a secure private registry with Azure Container Registry, or ACR. Once our registry is created, you can interact with it using Docker tools, Maven, whatever your favorite Docker client might be. All right, our container registry is ready. And we're going to push to the registry using the Docker plugin for Maven. To do that, we'll need the registry URL, password, and username. I'm going to export those variables as environment values so we can just use them throughout the demo. And frankly, I don't really want to show you my password on screen, so let's go ahead and do that now. First, we're going to get the URL, and we're going to query the login server property from the container registry we just created. The default user is just the name of the registry that we created, and here I'm going to pull the password that's automatically generated for us when we create the registry. Now let's take a look at the Maven configuration. Maven supports two forms of settings. You can have per user and per machine settings. Here, I'm just using per user settings, and as you can see, I'm referring to those environment variables we just created. All right, let's flip over to our POM to see how these values are used. What you'll notice is that I've added a couple properties to our top-level POM. The first is just the name of the registry, and the second is an image prefix. This basically defines how our images will be named once they're built. Farther down in the plugin configuration, I'm just specifying the server ID for the configuration I created in settings.xml and the URL where we're going to push our changes. Okay, I think we're ready to go push up to our Azure Container Registry using Maven. Let's give it a shot. If you've been through this process before, you're using Maven or a different Docker container registry, such as Docker Hub or somewhere else, most of this process should feel pretty familiar. Here, our image is built, and it's just getting pushed to the registry. Cool. Let's make sure it's there, though, before we proceed. And I'll do that just by listing the available images in our newly created registry. And there it is. There's just one since we just created this, but you can put as many as you'd like, and you can create additional repositories as well. All right. Next, we need a place to run our app. And two of the most popular choices for Java customers today are Azure Web Apps and Azure Container Service. We'll start with Web Apps, our platform as a service offering for running web applications. It's really a great choice for standalone web apps built with Spring Boot, Spring MVC, and the like. First, we need to create an app service plan. The service plan is used to specify what level of scale and availability is needed for the app. Here I'm using the standard SKU, but there's also a free tier. Next, we'll create our web app with that service plan. Okay, cool. We've got our app service plan. We've got our web app created. Now we need to tell our web app where to find our container image. We'll do that by specifying the image name, registry URI, and respective credentials. I'm going to use those same environment variables we created earlier, again, so I don't need to show you my password, but this is also how I'd recommend it if you're deploying from something like Jenkins or a different automation environment. All right, we've got our container pulled into our web app. Now we just need to tell the web app what port the container is listening on. There are a couple ways to do this, but the way that I find the simplest is to just set the port explicitly in the web app's configuration. This is a useful command to remember if you need to set additional configuration values in the future, so I'll show it to you now. Cool. And we have our web app all set up, so I'm just restarting the app at this point to pull the changes. Now, web apps do support zero downtime deployments, but we'll take the simpler approach for this example. Now that it's restarted, we can go ahead and browse to that URL. Just keep in mind, it might take a few minutes, so if you see a 503 or some other error, just give it a second and it should show up shortly. All right. Our app is up and running on an Azure Web App, and we're only 5 minutes in. I know the app isn't much, it's pretty basic, but I think you'll find those steps pretty repeatable in your own apps. So we got some time left, let's switch over to deploying to Kubernetes. In addition to web apps, a growing number of our Java customers are running their containerized apps in a cluster environment such as Kubernetes, Docker Swarm, or DCOS. Azure Container Service supports each of these orchestrators equally, and the process for deploying our app to it is pretty straightforward. We'll start by creating an SSH key for the cluster. Now, I could use the same SSH key I use for my own private use, but I always like to create a separate one for each cluster. It just keeps things a little bit easier to manage. You can certainly specify one you already have if you have one. Okay, now we can go ahead and create our ACS cluster, specifying Kubernetes as the orchestrator, and I can also specify things like the DNS prefix, and all of the networking will automatically get set up for me. Great. Now, from here on out, we can use the Kubernetes CLI. If we don't have it installed, there's a really simple command to just get it installed straight away. All right, if you're used to Kubernetes, you should feel at home at this point. All we need to do is get the credentials to our new Kubernetes cluster in Azure Container Service and set the default context for kube control. Let's do that now. All right, now let's check out what contexts are available. As you can see, I've done this demo 1 or 2 times before, so I've got a lot here, and I want to specify the one we just created as our default. Cool, now we're all set up and running. We have kube control talking to our new Kubernetes cluster, and we can use any old Kubernetes commands that we normally would use for Azure Container Service. For example, let's say we need to specify a namespace for our app. We can go ahead and run that now. Additionally, we want to pull our container image from Azure Container Registry just like we did for the Azure Web App. So we're going to specify in almost exactly the same way. This is really where those environment variables are coming in handy for the purpose of the demo. I'll save that configuration so I can use it later. And now I can just go ahead and run the app. Again, specifying the specific image that I want to run. I could specify a different tag here. We're just using latest in this case. And now I'm going to expose that deployment on port 80. Again, this is really pretty similar to what we did for the app service earlier in the demo. We're just doing it on Kubernetes in this case. All right, our service is exposed, our app's up and running. Let's check it out in the UI. We can just go ahead and browse to that directly using the Azure CLI, and we'll see the browser come up. And in here is our newly created deployment running our container image, and you can see all the replica sets and nodes available. That's it. Let's recap what we walked through today. We began by creating an Azure Container Registry for our container image repo. We configured the Docker plugin for Maven to push the image to the registry using the Azure CLI, and we created a web app to run our Spring Boot app. We then repeated the process for the Azure Container Service and Kubernetes, giving you two simple and effective ways to run and operate your Java app on Azure. If you're interested in diving deeper, check out our Azure Java Developer Center for a comprehensive list of tutorials and docs. You can learn more about what you saw today and explore some of our newest services popular in the Java community. A couple that I'm really excited about: MySQL support, Postgres support, and MongoDB, all fully managed database services. And now that you've seen how easy it is to deploy your existing Java apps to Azure, I invite you to try it on your own. Go to azure.com to get a subscription and start deploying your apps today. Thanks.